We appreciate you attending. My name is Valdi Wiederpass. This is, in case you don't realize, this is the Susquehanna group of Sierra Club. Welcome to tonight's general meeting. It's going to be featuring a presentation on climate change with a little twist. It's conflict or consilience, and exploration of science and religious stewardship. So you're going to get a little different angle on climate change tonight. These meetings are free and open to the public. You don't have to be a member of Sierra Club to attend, but we encourage membership as it helps us by providing funding for our activities and lets us know your contact information so we can update you on important matters. The December edition of the Susquehanna Sierra newsletter was mailed to members, and it's also available on our website. You can search for Sierra Club Susquehanna Group, and you'll find that website, which also has recordings of past meetings with past presentations for roughly the last little more than 2 years now, as well as newsletters, a calendar of coming events, and other information. Also, for our next newsletter, which is coming out in March, you can write an essay about whatever you're interested in that want to research and tell us about, and submit it to Sierra Club Susquehanna Group at gmail.com and for consideration to be published. New York State is more than 3 years behind on its 2030 climate goals. That was discussed in the September newsletter. We could still use some help with our group, and especially if you can at least contact Governor Hochul's office and urge her to be a real climate leader and follow our climate law. It's so bad now that she's even stopped talking about climate. Our upcoming events, we've got next month, February 7 p.m. the 17th, it's going to be a talk on the 363 Gateway Project, which is a reconfiguration of an intersection in downtown Binghamton to recover some green space. And Tom Bolander, as well as an archaeologist, are going to be involved in doing the presentation. I think the archaeologist is going to be the main person. Then in March, the 17th, it's going to be titled Gardening. So that's going to be by Karen Anderson and Sarah Hodder, Master Gardeners. April is going to be Anna Llewellyn talking about wildlife rehabilitation and secondary rodenticide poisoning. And you mentioned there's going to be a movie presentation. That's going to be the end of this month? Is that what it's going to be?
March 31st.
March 31st.
Here at the library, we'll have a movie called Earth's Greatest Enemy. We're lining up with the local peace group to put it on, and it's about the U.S. military, who's the world's largest polluter. So if that interests you, you should come. There'll be more information about that put out, though.
Okay, thank you, Scott. Okay, so we're pleased to have Dr. Tom O'Brien here tonight to help us explore highlights of the history of our scientific understanding of climate change and the ancient to modern religious perspective of stewardship of our common garden home, Spaceship Earth. Consilience, rather than denialism, of Judeo-Christian and scientific perspectives provide leveraged power to create a win-win synergy between sustainable economics and ecology. Dr. Thomas O'Brien recently retired after serving for 38 years as a professor of graduate-level science teacher education and educational leadership at Binghamton University's Department of Teaching, Learning and Educational Leadership. He's the author of the 3-volume National Science Training Association's press series, Brain-Powered Science, Teaching, and Learning with Discrepant Events, writer for the ACS Chemistry in the Community textbook, and co-principal investigator for numerous curriculum and professional development grants. His work has been recognized with awards such as the SUNY Chancellor's Award for Excellence in Teaching and the Science Teachers Association of New York State's Felllows Award. He is committed to promoting scientific literacy, environmental advocacy, and ethics-informed citizenship. Thank you, Tom, for agreeing to do the presentation and for your long service to the community and to the students that you have helped become teachers to then go spread the word about important things that we need so that we can do the right thing. Thank you.
Thank you. And welcome those who made it out on this cold night, those who are sitting at home with popcorn, and those who will watch this perhaps on a delayed venue. Little truth in advertising. I've got a lot of ground to cover, but mainly what I want to do is uncover some powerful ideas, and particularly the consilience, and we'll define that in a minute, between science and religion. So in the spirit of uncovering things, we'll start by unveiling. I'm known at the university for, when I was younger, I could have as many as 6 t-shirts on. We don't have that tonight, but we've got a couple. So science is awesome. I'd also like to mention that religion is awesome as well. Very popular song in the Christian circles is "Our God is an awesome God." And so my intersection on these two, I was raised a Roman Catholic. I went to Catholic grade school. I went to a public high school. I student taught in a public high school. I went to a Catholic college with a degree in chemistry, environmental issues, and education. So I was certified to teach. I taught elementary for a public school, and then taught at a Catholic high school, chemistry, physical science, math. Went to a public university for a master's and doctorate, and I've been at BU until recently for 38 years. So I've been in and out of Catholic and public schools as teachers and as students that whole time. And as a chemist and a Catholic, I've never in my life seen any conflict between those two. And so tonight we're going to take a little bit look at that intersection. The religious focus is going to be on Judeo-Christian. I had the good fortune to start studying Buddhism in high school. There's also a whole lot of overlap with Buddhism, but we have more than enough to cover in an hour and 20 minutes or so. I teach at the university. When I did, were 3-hour classes. So one approach would be I should just talk really fast. I'll try to avoid that, but there is a lot of ground to uncover. So let's get going here and see what we can do. So there we say begin with the end in mind. Mark Twain was one of my favorite writers, and he said nobody is saved after the first 20 minutes of a sermon. So the first 20 minutes, I hope to have the main message out there. And the main message is this: particularly since COVID hit us, there's been a lot of bad news, a lot of gloom and doom, some justified, some not. And a main message of the Judeo-Christian tradition, from the Jewish Old Testament to the Christian New Testament, is hopefulness. If you look up, interesting enough, fear, money, and hope are among the top 5 terms in the Bible. And so I'm going to be referring to a lot of the slides are going to have a lot more information on than I'm going to speak to. But assuming anything tickles your fancy or your interest, I'm going to show things like a YouTube clip. This particular climatologist has a really neat YouTube talk, 17 minutes. Most YouTube talks are around 12 to 17 minutes. And a really neat book called Saving Us, A Climate Scientist's Cape for Hope and Healing. And as a 19-year-old cancer survivor, a message of science is hopefulness. And as a Christian, a message of religion is hopefulness. So those two overlap, many at that. Her talk was titled, "The Most Important Thing You Can Do, Fight Climate Change, Talk About It." So I'm doing that tonight here. And hopefully the talk that leads to action. And so the latter part of the presentation, we're going to look at concrete things that each of us can do now. We don't have to wait for the federal government to step up. One of those things, though, we also need to pressure the federal and the state government, as Valerie said. Okay, this is an expanded version, so I'm delighted to have a little more time, from a series that I've been giving at Copernic Observatory and Science Center. If you don't know about that place, I highly recommend you check into it. Through most of the year, except these very cold months of winter, we have Friday night programs, and I've done 3 on this broad area of science and religion. And I need to have one slide on the first 2 just to cover sort of the ground. So the word consilience. Consilience is a word that's imported in and outside of science, and it ties to the Greek notion that all knowledge interrelates. And so consilience is when you have evidence from different sources, be they different fields of science, be they outside of science like religion, where they all converge on the same ideas. And there's a lot of consilience, not complete by any means, but there's a lot of consilience, particularly around when we looked at the word, as it's mentioned particularly in the New Testament, logos, of course, is logic, reason, and the cosmos. Those terms, those Greek terms in the Bible was propagated largely through the Greek language. The language, even for the scholarly Romans, was not Latin, it was Greek. So the logos, the word, the cosmos, the order in the universe. Science and religion both take different takes on that. And my personal take is both are necessary. Neither alone is sufficient. And again, that's my personal take from having studied this a lot since high school. I've been very, very interested in this intersection since then. The second talk was on evolution. Lots of misconceptions there. But the part that is most relevant here is that both evolutionary social psychology and religion say largely the same thing. We have it in our genes, if you will, or in our spirit, if you will, both elements of compassion and love and caring for others and selfish self-centeredness. And it turns out most of biology works not just because of competition, but actually because of cooperation. And we're going to get back to that a little later at the cellular level. The basis of all life is actually cooperation, not competition. We'll get back to that. So that's the second talk. Here we are on the third one. And the take-home idea, the image. They say a picture's worth 1,000 words. The concept of Spaceship Earth is mind-blowing. So I was in 1868, I was 6th, 7th grade, I guess. And when these kind of photos start cropping up, and then in 69, we landed on the moon. Just so they're on the screen, so people have them if they want to view it delayed. So that was the first slide, title slide, second slide, third slide, fourth slide, and this is where we are. So this idea of Spaceship Earth, this picture is probably worth the whole space program, because what it presents is an idea that philosophers, writers, scholars have spoken to. Walt Whitman said, "One thought ever at the fore, that at the divine ship, the world breasting time and space, all peoples of the globe together sail and sail the same voyage, or bound to the same destination." Circa after Civil War. George Orwell of 1984 fame, that in many sense looks remarkably like what's going on in the world, said the world is a raft sailing through space with potentially plenty of provisions for everybody. The idea that we must all cooperate, but one would say no one could possibly fail to accept it unless we had some corrupt motive for clinging to the present system. I mentioned the talk is largely about science and religion, the interface. As I was talking to a couple of people before the presentation, we can't talk about climate change without politics. But clearly there's a political statement here, which I think is a spiritual and a scientific statement. But that one would say that no one could possibly fail to accept the fact that we're all on one planet together, unless he had some corrupt motive for clinging to the present system. What would you be talking about? So the Bible story. So the biblical story of the Garden of Eden, and let's just take it as a metaphor right now, rather than as a scientific fact. But the language you've all heard, whether one's a Christian or not, be fruitful and multiply, fill the earth and subdue it, have dominion over it and every living creature. That oftentimes is mistranslate those words to be this dominion over, like we're in charge of everything, we're the king. That's not what the Bible intended. And later verses make that clear. The Lord God then took the man and settled him in the Garden of Eden to cultivate and care for it. So the concept of stewardship is built in the Judeo-Christian Bible in spades. That we have this role to take care of things. And one way of thinking about metaphorically that what the fall from the garden was an overemphasis on me, mine, I. To the extent we hear that in politics, that should raise a red flag, because science is about collaboration and so is religion. And then maybe our decision to disobey God, again, we'll take this metaphorically now, and eat from the tree of knowledge of good and evil, was to supplant the rightful creator's value system, which was about collaboration, the lion sitting with the lamb, etc., and to substitute that with our values, which are about me, my, and what I have. And that creates illness versus a more community focus on wellness. So again, a little touch on religion there. And that technology's going away. So let's take one more look at Spaceship Earth. Probably the most famous quote that some of you may have heard. My focus in my freshman year in college was on environmental science and interdisciplinarity. It was a very unique program I was in. So we looked at economics at the same time we were looking at ecology, and the same time we were looking at Buddhist literature as just a fascinating mix of things. But this phrase, Adlai Stevenson ran for president twice and failed both times. He was deeply devout Unitarian, and we'll talk about that a little later. But this phrase, we travel together, passengers on a little spaceship, dependent on its vulnerable resource of air, preserved from annihilation only by the care of the work, and I will say the love we give our fragile craft. No craft, no crew can travel safely with such vast contradictions. On their resolution depends the survival of us all. That speech to the UN spawned several books which were instrumental in 1974 for me about the operating manual for Spaceship Earth. And so we have this beautiful image of the Earth. Religious take. Yesterday was Martin Luther King Day. In the past, we had free passage to all of our national parks. That was canceled this year, which is a very curious thing. But two takes. Martin Luther King himself said, injustice anywhere is a threat to justice everywhere. We're caught in an inescapable network of mutuality, tied in a single garment of destiny. Whatever affects one directly affects us all indirectly. This is the interrelated structure of reality. Religious perspective. Science perspective, John Muir, who's dear to the heart of Sierra Club, John Muir, was a multidisciplinary scientist. He said, when we try to pick out anything by itself, we find it hitched to everything else in the universe. So again, there's consilience between a religious perspective and a science perspective there. A couple more thoughts from Martin Luther King. Science and religion, whether they were complementary and or whether there was consilience. He said, science investigates, religion interprets. Science gives man knowledge, which is power. Religion gives man wisdom, which is control. Our scientific powers outrun our spiritual power. We have guided missiles and misguided men. So some very powerful thoughts that apply to Spaceship Earth. What I'd like to do, just a little dive in as a science teacher, and a little bit of the history. If you had the chance to watch Julian Shepard's talk last month, and if you didn't, check it out on the Sierra Club website. Did a great job. Deep dive into the science. I'm going to hit science, but I'm going to hit some older science that's maybe not as well remembered. So Lavoisier, time of the American Revolution, French Revolution, known for many things, developed much better gunpowder that fueled the American Revolution. But in the science realm, his claim to fame was the law of conservation of matter. And essentially what he figured out is that in any chemical reaction or physical change, if you weighed everything, and we'll get to why everything matters, at the beginning and at the end, all the dramatic changes you see, mass stays constant. Think back to that image of Spaceship Earth. Essentially, that's like a big flask with a stopper on it when it comes to matter. We lose very, very little matter, a little bit of hydrogen, helium. We gain very little bit, meteorites that don't burn up before they come in. Essentially, we have a big closed vessel. So every atom that we have 100 years ago, we'll put nuclear aside, every atom that we had 100 years ago, 10,000 years ago, we have those same atoms today. And all the changes, chemical and physical changes, are simply those atoms changing partners and locations. He was a devout Catholic, as was his chemist wife as well. So this is what it would be if you tried to show it in a lab setting. So the simple reaction between baking soda and vinegar, which most people as kids, somewhere along you did that, and it fizzes and sort of cool. It's a great way if you have your drains are clogged with hair and stuff. If you pour a little baking soda there and pour some vinegar on it, it helps clear the drains fairly well. Well, that reaction, the chemical reaction, and we don't need to say the names, but the important thing is if you count atoms. So if we count sodium, there's one here, there's one over there. The same is true for carbon, hydrogen, oxygen. Everyone counts. Now, if the normally way you do this, if you didn't have a balloon on it and you weighed it before and you weighed it after, there'd be a difference. Afterwards, the weight would be less because you would have lost CO2. But gases matter and have mass. And that's going to be really important to talking about global climate change. Gases matter and have mass. And that applies to the whole spaceship Earth. Another guy, Joseph Priestley. Curiously, I mentioned before, Adlai Stevenson was a member of the Unitarian faith. For the locals here, down on Riverside Drive is the Unitarian, right next to Lourdes Guthrie. But right on the right there, they have great cranberry coffee houses there. If you like folk music, sort of throwback from the 60s and early 70s. The Unitarian faith was founded by this Christian minister in England by the name of Joseph Priestley. Did lots of cool things. A book that's absolutely fantastic if you like history of our country and you like learning about science and the intersection is The Invention of Air. But Joseph Priestley did all kinds of things. He was good buddies with Benjamin Franklin, Thomas Jefferson, John Adams. But for our purposes here, he discovered pure oxygen. Called it dephlogistonated air, which is a bit of a problem. Also was the first to work with carbon dioxide and made soda water. Soda water is what's happening to the oceans. Ocean acidification is CO2 from the atmosphere dissolving in the water and making the oceans more acidic. Dissolving calcium carbonate, which are all the shellfish and others. So he worked extensively with those two gases and sort of is the father of modern ecosystem science. So the father of a sort of Christian denomination. Thomas Jefferson, if you've never read his Bible, he threw out the Old Testament entirely because it was a vindictive God, he said, and he threw out every miracle in the New Testament. So when people talk about our founding fathers being all Christians, not quite true. Thomas Jefferson believed that Christ was the most brilliant, most loving, brilliant philosopher that ever lived. He didn't do miracles. He didn't rise from the dead. He's not the Son of God. Got some of those ideas from Joseph Priestley. The Unitarian faith includes like everything, anybody that has any sense of spirituality. So Joseph Priestley was a cool guy. If we put together Joseph Priestley's work with gases and sort of fast forward, simple experiments here, and did much more complicated. But if you put a mouse in a closed jar, if you put a candle in a closed jar, it goes out eventually. If you put a mouse in a closed jar, it goes out. The mouse dies. If you put the two of them, they both go out quicker. So something that a candle needs and something that a mouse needs is extracted and used up. Interesting enough, if you put a plant in, they last much longer. So something that a plant does puts something back in. So the second t-shirt for the day, if you took chemistry, chances are you had the impression that chemical reactions don't matter. They matter immensely. And this one here, we're going to spend a little bit of time on. It's reaction for photosynthesis. But essentially what Joseph Priestley figured out is that gases matter and that there's this complementarity between things that we burn and what we need to burn, and between things that we breathe and what we put out in the air. And that's really the most basic part of ecology is that. So there's the modern version, which is the t-shirt that I'm wearing shows this reaction. If you had to teach one chemical reaction, this is, quote, taught in 7th grade life science. It's taught in 10th grade biology. Chemistry, they barely mention it, and nobody ever learns what the real power of it. This reaction, this carbon dioxide from the air, what plants figured out is they can extract CO2 from the air and water and make sugar. And as a byproduct, they release oxygen. That is absolutely crucial to all life on the planet. What green plants and microscopic green planets in the ocean can do with that reaction. The interesting thing, the reverse is what all animals do. And normally the books leave it at that, but it turns out plants do both. They don't make sugar just for us, animals, but they make excess sugar and they make excess biomass. And that's where all of our fossil fuels, that's where wood, that's where all of our food comes from, the excess biomass that they make. But this reaction, you count atoms, it's the same one way, it's the same the reverse. Actually, if you count energy, there's a law of conservation of energy. It's the same. The energy that it takes in to drive it to sugar and oxygen is the same amount of energy that comes out if you burn it. Nature is incredibly balanced at this level. And this cooperation, it turns out that both mitochondria, which are in plants and animals, and middle school and high school books never show mitochondria in plants. So the assumption is, well, plants have a chloroplast and animals have mitochondria. Plants have both because they make sugar and they burn sugar. Both of these were independent. The basic eukaryotic cell that we have is made up of a cooperation. The mitochondria and separately the chloroplast were once free-living bacteria that got incorporated into another bacteria that didn't eat it. It didn't compete, they cooperated. And that made all the complex cells on this planet. So fundamentally, all of nature is wired around this fundamental cooperation. Evolution does involve competition, but at the most basic level, the planet and the universe is designed for cooperation. Don't need to go into details in this. The idea is to just summarize what I just said, that we have carbon being used by plants and either being eaten by animals and then eventually released as CO2, or this here, during unique periods in Earth history over hundreds of millions of years, plants, rather than just decaying on the surface, if you go for walks, it's beautiful to see all the different types of plant life and fungi that are breaking down dead plants to make new living plants. But during the period in the distant past, over hundreds of millions of years, the carbon got sequestered, and largely plants, because they're way more mass than animals, got turned into fossil fuels. And for most of human history, this was inaccessible until the Industrial Revolution. So those two cycles, the main point is that there is this recycling of carbon and oxygen, and we have the potential, which it has been throughout most of history, to be balanced. And what helps that balance is the Earth atmosphere. The Earth atmosphere as a metaphor is actually less than the thickness of an apple compared to the total diameter of an apple. That for the Earth is less than that. So it's a very, very, very thin skin. Think of it like a cell membrane. The Earth is semi-permeable. We let a little bit in the sense of matter, not much meteorites, and a little bit out, but we allow energy in and energy out. It's much more permeable to energy. And so that atmosphere supports recycling of elements, it supports the water cycle, and very importantly, it supports weather. Most of the weather happens in this troposphere area that's less than 20 kilometers from the Earth. Everything we call weather basically happens in that zone. And if you count atoms, almost all of the atoms are in almost less than half of that. Most of the gaseous molecules are in the very, very, so it's a very thin layer that protects the Earth. And so what is that made up of? Well, that lower level as a whole is largely made up of nitrogen. We breathe it in, we breathe it out. Most creatures do not use nitrogen directly, and yet nitrogen is part of every protein. It's part of DNA. Most animals have no way of using it. We breathe it in, we breathe it out. Nothing happens. Fortunately, there are bacteria that know how to capture it, nitrogen-fixing bacteria, and blend it into the system. But mainly we have nitrogen. We have oxygen is next, about 21% by volume, and then smaller amounts of everything else. So to give you a perspective of that, Scott, can you give me a hand here? I'll just move this over just a bit. So it's grab it from the top, and we're just going to slide it.
Oh, hold on.
All right. We'll reconstruct here. So what I have here if you look on your water bills, if you're a homeowner, one more fix. If you look on your water bills, you'll see that various components of water are listed in parts per million. And certainly when we talk about global climate change, we talk about the percentage of CO2 as parts per million. Most people don't really know what that is. So what I have here is a cubic meter. So it's a meter long, a meter wide, and a meter high. And it turns out that that's the basic unit of volume. Typically wouldn't find milk or gasoline in that, but that's your basic unit of volume. But it turns out very interestingly, if you think a sugar cube is a little more than a centimeter cube. So I have a centimeter cube here. For the audience, I don't know if you can quite see that. We'll have it for the people here. We'll put it right on top. That's a centimeter long, a centimeter wide, and a centimeter high. I could fit, if I line them up, and we'd need a very long presentation, I could put 100 this way, 100 that way. So one level, I'd have 100 times 100. Then I could go up 100. That's a million. This little cube, centimeter cube, think again, roughly a sugar cube, inside of a cubic meter is 1 part per million. So back to this here, we can now see what these part per millions mean. Mainly, the bottom here, blue on the diagram, would be mainly nitrogen, which is unavailable for most life to use. Oxygen, which most organisms depend on, is sort of the next level, that's sort of 20% level. Then we have helium, neon, carbon dioxide through most of all of human history. If we count humans being 300,000 years, Homo sapiens, that concentration has been fairly constant that whole time until recently. How are we doing? Is there any question on this much? Covering a lot of ground, but what's that?
We're coping.
Coping. The nice thing, if there's anything you're interested in, you can come back to the slides later. But so since the revolutionary era, which overlaps with the industrial era, when our economy started burying this buried sunshine, if you will, burning coal and eventually oil and gas, is when we've had problems. And so Julian did sort of the modern history. I'm doing the history before what Julian talked about, for those who caught his talk. And so this period from about the 1820s, so by then chemists were clear about atoms and molecules and some basic idea of bonding, up to the 1930s when we start figuring out subatomic particles, or subatomic particles, I should say. But along the way, the notion of carbon dioxide was really crucial. And carbon dioxide, walk off screen here. As the name suggests, carbon and 2 oxygens. And it looks sort of like this. Now, atoms are way too small to reflect visible light. So anytime you see models, atoms don't have color. To have color, they would have to be able to reflect visible light, of which they can't. Anytime you've seen pictures of atoms, they're made up. Because to see, you have to visible light hit something. Now we talk about electron microscopy, and we have fuzzy images of atoms, but you have to believe in subatomic particles called electrons, which are part of atoms, to believe the image. So our basis for believing in atoms is not visual information at this level. But this carbon dioxide, what they figured out starting in the late 1800s, and they didn't know the bonding, but I'll put the modern interpretation. When they get energy, they can vibrate. The bonds can actually vibrate. They can turn, the whole thing can turn, the whole thing can move. But this right in here is where the problem with global climate change comes in, which we'll return to level. But that has the ability to absorb what we call infrared radiation in modern language and hold on to it. So think now that this beautiful semi-permeable blanket now is not allowing heat to escape. We'll go a little more into that shortly here.
So the infrared energy is sort of like making a bond resonate?
Yes. Think of pushing, I would love to go off on chemistry. Think of pushing a person on a swing. If you want the person to go higher, you have to hit it at the right frequency. IR is the right frequency for the C double bond O.
Oh,
So you're hitting the swing at the right frequency.
okay, thanks.
Yeah. What a great word, resonance, I would say. If we go forward, we discovered some other things along the way. The notion that the ocean was acidifying. So Joseph Priestley initially thought that CO2 dissolved in water would be one of the best health things. And it turns out it does make you burp if you have an upset stomach. But what we did is we threw tons of sugar in it, making it poisonous. Carbonated soft drinks have the equivalent of 17 sugar cubes. So when you have your little can, 39 grams, that's another presentation, is 17 sugar cubes. But in the ocean, we're not putting in the sugar, but we're putting in all the CO2. So we're making, and the best use of carbonated drinks is they're great for cleaning out inside your toilet, the buildup of calcium. It dissolves your teeth like that as well. And then makes a space for bacteria for the sugar. So it's just the perfect environment if you want to destroy your teeth. But back to climate change. So what we really figured in that time frame is that what was going to be happening was the Earth was going to be getting warmer because we were increasing CO2. And actually, Joseph Priestley and Ben Franklin talked about taking trees out of the equation because they were denuding England and putting CO2 into the atmosphere. They have letters that I've read parts of where they were actually talking about we're creating an imbalance. So concern with climate change is not a new thing. It goes back. One idea which was really pivotal in my freshman year in college was an article called The Tragedy of the Commons. And the commons is something that everybody can use freely. And we have controlled throughout history with controlled water. Many places in Colorado, I taught one summer at University of Northern Colorado, Greeley. They have watering systems underground that transplanted Eastern ecology, Kentucky bluegrass and other plants from the East Coast here, over to Colorado. And these water rights go back to the 1800s. So they massively waste. So up in the morning at 7 o'clock to go teach, you come across campus and water was rolling off of asphalt. So we have controlled water rights, sometimes in really crazy ways. Nobody's figured out how to control air. The lines that we see on the map when the astronauts looked at Spaceship Earth, they don't see lines. And we don't control air. And so air is the classic case of tragedy of the commons. We can take stuff out of it, we can put all kinds of garbage in it, and nobody pays. And so the atmosphere, air pollution is a tough nut to crack. And we need national and international support. Last slide on the history. A couple pivotal things happened. Late 1980s, a former NASA scientist presented to Congress and said, we've got a problem. And I think Julian's alluded to that in his talk. What also came out, though, in the 70s was the first Earth Day. I was in 8th grade at the time. And the Environmental Protection Agency under a Republican president, President Nixon, was established. In 88, we had the United Nations IPCC panel, which is still very much in the news. So good thing, we were starting to recognize we need to do something. Fast forward to the end of that, 2015 to 2025 has the 11 hottest years on record. And the last 3 were the highest in 176 years. Bad problem, getting worse. A concern. So where does that come from? Well, interesting graphs. If we plot atmospheric carbon dioxide, it tracks, as you would imagine, emissions. But basically, there wasn't much change until the Industrial Revolution really kicked off, in particular oil, the burning of oil, and then later natural gas. They really accelerated along the way that we're increasing. So that amount, which started off at more around 200, now has increased. That's our parts per million of carbon, those black. So we're increasing that dramatically in our lifetime. And where is it coming from? What's coming from fossil fuels. So about 83% of the total energy that we use in our country is either natural gas, petroleum, or coal. All of those produce CO2 when you burn them. Essentially, the reaction for cellular respiration, the reverse to photosynthesis, that is a carbohydrate being oxidized, burned, if you will. Every cell in your body burns food. The brilliant thing about life is they figured out how to burn food without a flame. But every cell in your body has mastered how to burn sugar. And it releases it in little tiny energy packets rather than a flame that a candle or a lump of coal would do. So, and what we're doing simultaneously is we're cooling up all this buried sunshine, hundreds of millions of years of, again, largely plants that have turned into fossil fuels, and we're burning them in 100, 150 years. That's an imbalance to this whole system that is balanced. And at the same time, we're deforesting the planet. The Amazon is being massively cut down, largely to support short-term production of red meat, cattle. It's a double whammy, triple whammy. You're taking out the lungs that process the CO2 that we're producing. You're producing cows who not only burp CO2 like we do, but they burp methane. And it sounds bizarre. It's actually true. A significant portion of the second biggest global greenhouse gas is from cows' flatulence, burping in the other end. So we're doing two things that are both making what I would have learned in my freshman year is a positive feedback loop. A positive feedback loop isn't positive. It's a system that feeds itself and you get more of the same. So we're getting more and more of the same. That is a very negative positive feedback loop. We mentioned before about the Earth's atmosphere, greenhouse gas in a nutshell. This filter, the gases that we have filter out almost all of the high-end UV, which causes cancer and destroys DNA and blindness, filters almost all that, but lets the visible light that we see things with, allows the invisible infrared that warms the planet, and a little bit of the good UV. So this blanket is designed to be semi-permeable like a cell membrane and let those good things in. It largely keeps out the high-end UV that causes problems. The separate issue is that the Montreal Protocol did a lot with is the ozone hole. And that's about messing up that filter. But this natural greenhouse, the fact that we have this brilliant atmosphere allows us to have livable temperatures on the planet, rather than super hot or super cold or super fluctuating like all the other planets. So the downside, so the greenhouse effect is absolutely essential to life on this planet. And we had this system, again, balanced for more years than human beings have been here, more than 300,000 years. It was carefully balanced. And then again, over the last 100 or so, we've greatly increased the CO2, also methane and dinitrogen oxide are three of the key global greenhouse gases. And what that's providing is we let the higher energy in, but then the infrared gets trapped, and it gets trapped back to Valdi's resonance. This molecule doing this does it from both sides, but this is fixed. So. And it absorbs and keeps that heat in. So that infrared that normally would have escaped is now blanking, and we're getting warmer and warmer. This is a whole lot of science, and I'm going to only touch on a couple of things that are highlighted. Physical changes involve energy changes. So if you take ice, you heat it, it melts. We all know that. What most people don't realize, if you take liquid water and heat it, it turns to steam. We know that, but it takes a whole lot more energy. This part here, this water to steam, is largely what controls hurricanes and lightning and thunder, all the energy from lightning and thunder, because the law of conservation of energy says that the reverse, if it takes energy this way, the same amount of energy comes out this way. And so if the planet warms and we put a whole lot more moisture into the air, when that moisture eventually condenses, it creates lightning and thunder, and hurricanes and typhoons. All of that stuff comes from the simple energy that when a gaseous water molecule condenses, it releases truckloads of energy. Truckloads of energy. So that's an important point. It's called the heat of condensation. And the last point, which is relevant in the news now. So simple experiment to do if you have a glass with some water and ice in it is make a mark on the glass where the water is. And then the question is, when the ice melts, where's the level of the water? The options are up, the water is risen, down, it's dropped, or it stays the same. Any takers on that one? How many people think the water level goes up? Raise your hand. Okay. How many people think it goes down? Stays the same. And that's a whole science lesson we won't get into why, but cool stuff called hydrogen bonding. But the part that's bothersome is that, so icebergs floating in the water, when they melt, doesn't change the level of the water. Screws up the planet in all kinds of ways, but it doesn't change the level. But the reverse, if you're Greenland, if you're Iceland, if you're Antarctica, the South Pole, those are all land masses that have truckloads of ice on top of them. When that melts, and you could do that experiment, have something extended in your glass and put a piece of ice on top of it, and when the ice above the water melts, the water level rises. That's a massive problem. And all the coastal areas of the world are already at risk, and some of them, there's some islands that will be deserted in the very near term, like the next couple of years. So 2 main points about physics, chemistry of water changing phase. Lots of energy comes out when water condenses, and that means if you have more moisture in the air, you're going to have more storms, and they're going to be more violent storms. And they could be winter storms, they could be summer storms, anytime. And we have lots of evidence about going on. And then the water level rising. So was this known? Yes. It's been known for a long time. There's been a massive cover-up. Our own BU Nobel Prize-winning chemist worked for Exxon when he made the first lithium-ion battery. I don't know if you've ever had a chance to talk with him or be at a presentation. He left Exxon because they had no interest. His original lithium-ion battery, he has at home, and it's still powering a clock, I think it is. Exxon had no interest in that. In the era I was teaching, from 77 to 82, 83, President Carter came in. He put solar panels on the White House. We had extensive education materials that were interdisciplinary. So I used the materials in teaching. They had kindergarten through high school. They blended economics, social studies, history, math, and science. They were brilliant, and they were free. Right when we shifted administration, I got the note I sent for the last packet of this really interesting curriculum that, if I had it today, is still better than most of what I've seen, because it was really brilliant, interdisciplinary. I got a letter saying that you need to understand that it's the official policy of our government that there is no longer any energy crisis. Therefore, there is no need for energy education. These materials are being warehoused to be burnt without energy capture. Energy capture was something we talked about, but capturing waste energy from burning stuff. Therefore, it's illegal to send these to you. And he sent them to me, which was wicked cool. And so the writing has been on the wall, as far as I'm concerned, since I was a high school teacher. And it's just ridiculous, just absolutely ridiculous, the ignoring of science. And there are actually some really interesting stuff from the Union of Concerned Scientists. These articles you can click to called Decades of Deceit. And they use the same techniques that the tobacco industry used to tell people that cigarette smoking didn't kill people. So as a 6th, 7th, 8th grade, I was trying to convince my father that tobacco kills you. And listening to the tobacco industry, he really didn't listen. We knew they used many of the same techniques. Curiously, fast forward to the modern food industry, the tobacco industry's bought some of the food companies, and we're using these same techniques to make food that's not good for you addictive. So really cool stuff. That could be a whole talk in and of itself, but just touching it. Here we have the home company, our NICET. So this is the industry speaking. This is a Spanish company that owns NICEC. And this is directly from their website. They say climate change is going to cost coastal areas a lot of money with rising seas. It's going to lower the capacity to work due to heat. This is happening over the world. We're going to have more wars. Fresh water is going to be in short supply, blah, blah, blah. This is horrible stuff. This is the industry telling you the truth. And it turns out in my lifetime, we've gone from millionaires to billionaires to soon perhaps a trillionaire. The gap in wealth that's happened in our country is unbelievable. And that's upsetting the whole balance of the planet. And so for a lot of people, life is going to be increasingly about surviving, whether we have this brilliant system set up that allows everyone to thrive. There's no reason anyone is hungry on our planet in terms of science. You can do the calculations. We actually produce way more calories on this planet than we need. Food industry has the highest waste of almost any industry around, from the point of production in the fields to the point of people throwing it away at home. It's massively wasteful, which causes more global greenhouse gases. Back to Martin Luther King. So I want to give a little take into religion here and then get to the practical application stuff. Martin Luther King talking about the civil rights, but he would be, I think, the first in line to say that social justice is part of the global crisis with greenhouse gases. We're now faced with the fact that tomorrow is today. We are confronted with the fierce urgency of now. Now is the time. Life's most persistent and urgent question is, what are you doing for others? What are you doing for others? It'd be nice if that was the focus of politics. What are we doing for others? So flash forward then to when did we start paying attention to this at the public level? Scientists knew back in the late 70s. A couple of things happened. I referred earlier to the NASA scientist who presented to Congress in '88 that says, we got to get tracking this problem. Popular, this book, and it matched much of the stuff I was reading in the early 70s, was overly doomsday-ish and a little bit too hippie-like, in that, you know, everybody had to eat then pretty nasty tasting Greek yogurt and, you know, be cold but it was a shock that got out there. This organization was founded. It was at the point it was founded, we were already at what they considered the tipping point. And today, January 26, 428 parts per million. Again, we were 280 back 100 years ago. Al Gore got a lot of fame for his Inconvenient Truth. The movie, and then the first two books where he talked about it. And a question and an approach in terms of what we can do. If we promote only gloom and doom, is that going to convince people, if you believe the problem isn't solvable, you're right. Conversely, if you believe the problem is solvable and that along the way there's all other kinds of problems that will be healed at the same time, you're probably right again. So the question is, can we take negative anxiety and anger, of which certainly there's justifiable anxiety and justifiable anger, but can we convert that into positive attention and actual concrete action? And yes, we can. So the UN in 1995 had the first annual meeting that focused on global climate change. 195 nations. 10 years later, at the 10th conference, they actually agreed that to set a limit on how much the planet could get warmer, and agreed to voluntary emissions controls. Very exciting, 10 years back. And the idea was that we could set up a win-win, that we could have economics, which is home numbers. Eco means home. And ecology, the science or study of our home, in this case, our planet, Spaceship Earth, that we could have win-wins things set up, and the technology could be advanced. We could have more jobs. We could have the world acting as one. We are related not only to every human being on this planet, you are related to every organism on this planet. Christians would say brothers and sisters in Christ. The Buddhists would say we're connected to every organism on the planet. And that is true. Albert, his last book was the Call to Action book and film. Leaned heavily on clean green technologies and this notion of win-win, that the economy could work out better and the ecology could work out better. And if we think what's happened, we have hybrid vehicles, plug-in hybrids. I'm coming up on the 2021 plug-in RAV4 has a gas-only range advertised of 38 miles. In the winter, it does 41. In the summer, it does 53 to 54. My average mileage on the car, so it only gets, say, 50 miles here locally. Most of my driving is local. The last time I looked, the 4-year average was over 70 miles per gallon equivalent. And even with rising prices of electricity, it's way cheaper than gas. So we've had real, and the Chinese, unfortunately, are making just godzillions of money on solar, wind, and electric batteries. And we've allowed them to almost take over that market. But there are win-wins possible.
May I interject?
You can.
I heard an interesting thought today, and it was an historic perspective, which fits right in with what you're saying now. This historic quote went back to Spain relied upon slavery to grow its empire. Slavery, and I'll argue wind. Britain relied upon coal, steam. America has relied upon oil. And China, who is now making EV vehicles for $9,000, available at $9,000. Is that right? Will become predominant with renewable energy.
Well,
And
yes.
I fail to believe that humans will make these decisions for all the rational reasons you're referring to. And it will only be when there are no other alternatives.
Well, no, they don't have to be other alternatives. You just have to make money. So right now, the top wind and solar productions,
I think it's
exception
China.
of California, in America, are all Republican states. So Texas, Oklahoma, Arizona, Arkansas, I think, are the states.
And
I'm sorry, what?
wind.
Iowa's in it, yes, thank you. I thought there was one more.
Probably South Dakota too, maybe, not sure, but a lot of those Midwestern states have a lot of wind power.
Right, and curiously enough, right, politics in it. Well, the president says he doesn't like wind, so he's not paying attention to the Republican states. But where he is halting it is on the East Coast, where here we do offshore wind. And so judges have just rejected his plans multiple times now, just in the last 2 weeks. But he is specifically trying to stop the offshore production of wind because he cares about waves.
They have so much more something.
The windmills are up above. Anyhow.
I thought it was viewed from the Gulf.
Well, that's what he originally got ticked off. That was 10 or more years ago in Scotland, that he could see windmills from his
Yes,
golf
yes.
course.
Right,
Yeah,
right.
yeah. Let's. The main thing, if we talk about Trump, is that I want to mention is that the damage at the national and international levels. So we have a turning away from science, even beyond this. And it's one thing to have misinformation, to be ignorant, but to know better and to disseminate false information. And
Just
I can't speak to the president, but certainly his advisors and the people around him and whole agencies that he's trying to control, EPA and others, know better. He pulled us out of the Paris Accord. Biden put us back in. He came back in. He pulled it out again. We had the Infrastructure Investment and Jobs Act, bipartisan infrastructure law. He's basically almost wiped it out because Congress won't tell him he can't do that. We had a historic $1.2 trillion federal law. Over $850 billion of that was for clean energy and the jobs associated with that. He's removed that. We did not participate as a country in the last international meeting that just took place back in November. So it's a sharp counterpoint to President Trump, who's called climate change a con job and attacked global efforts to transition away from coal, oil, and gas. We withdrew from the accord. Not just we didn't show up, but we withdrew from any commitments to the prior things that we had voted on. So what are we doing? Geopolitical wars are predictable. If we look where the most oil reserves are, they're actually in Venezuela. Now, it turns out the press hasn't talked about the fact this is the equivalent of dirty coal. It's the worst, dirtiest oil you can get because it's thick, it's viscous, and it has a high sulfur content. Pennsylvania and the railroads in our country grew on anthracite coal, that hard, closer to carbon pure coal. Still not a clean fuel, but by comparison to the coal that we've been using for the last 30, 40, 50 years, anthracite coal is really good. We don't have any more. Well, this is the worst kind of oil you can possibly get.
Yeah.
And so contrast the UN. The UN, 15 years ago, roughly the same 195 nations voted on what they called sustainable development goals. Won't go through every one, but no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and air, blah, 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 blah. The nation said, and the interesting thing is, working on almost any one of these in a scientifically, and I would argue spiritually informed way, helps solve the other ones. They're all interconnected. That network of mutual impacts. And that's what UN would like to address, and do it within what they call safe operating spaces. That goes back to the Paris Accord, how much we're going to allow the planet to warm up. By contrast, our challenge is to educate ourselves and our communities. And again, the point in contrast, Julian was mainly talking about recent history of science, but I gave you a real quick heavy dose of was stuff we've known when our American Revolution was being founded. The basic study of gases and understanding that gases have masses that matter dates back to the founding of our nation. This is not new science. And yet we have all kinds of climate change deniers. Really fun video is this one here, which I had no intention of showing, but the League of Conservation Voters put it out about 12 years ago. And it's a science fair where a dad goes berserk, saying this is all anti-science. And then by the end, he finds his way. So it's a success story of kids convincing a dad. Again, the science is just completely clear. Science operates on not absolute proof, but it operates on empirical evidence, most often measurable, massable stuff, logical argument, which we come through the Greeks, and skeptical review. The first modern chemistry book was written in late 1600s by Robert Boyle. It was called The Skeptical Chemist. Skeptical isn't cynical. Skeptical is people that use empirical evidence, logical argument, and that's what science is founded on. So any one, you can't say that any one heat spell or flood is due to global climate change, but the fact that all of these metrics are going up very dramatically in an exponential way, not even a linear way, they're going up, is sort of consilience of evidence. So there's some other neat videos and things there. If you're interested. I'm not going to spend time on this, but we can call all of these pseudoscience theories zombie theories. You know, it's sort of like whack-a-mole. They just keep coming back. And so this notion of, well, there's really significant agreements of science. No, there's not. That what's really non-human factors, natural cycles of solar wind and volcanoes. No, it's not. Or what's real, but it's not in my backyard, so I'm not going to worry about it. Here we had the 100-year flood and the 500-year flood in Broome County just a couple years apart. That's no accident. And then either we can't do anything about it, or we just can't afford it. Those are lies. That's simply, none of that is true. What are we doing? The Paris Agreement actually slowed down the increase. And that's positive news. It slowed down the increase. But a recent report said United Nations announced that the world was far off track from keeping global warming well below the 2 degrees Celsius or 3.6 degrees Fahrenheit compared with pre-industrial levels. That goal was virtually every country agreed to 10 years ago. So this article came out in November and says we're not on path. Again, it could have been worse. And if we pull out of the Paris Accord, particularly America is one of the top producers, that's the path we're on. And in our lifetime, I care about my 3 adult children, but in my lifetime, that's going to cost us a whole lot of grief. Today, I read an email from Climate Power. There was one out in October, one out today. What words in the Department of Energy are they trying to ban? Climate change, clean energy, green emissions, and footprint. So this is 1984. We can't use the right words. And then this was from today. And you have probably experienced this. Household electric bills in the last year are up 13%. Some parts of the country more. I suspect in the Northeast more. Residential gas, natural gas for heating homes is up 60%. 169,000 clean jobs, energy jobs that would have been funded are gone. Disaster response, FEMA is slashed. Like, this is not good. And we're talking about invading and occupying Greenland. So this is foolish and foolish. It's anti-science, it's anti-religion, and we're on a predictable path to disaster. If we can predict something, we can prevent it. And it's never too late to do the right thing. So let's start bringing it home here. So our footprint. So each of us, we drove here, most of us, I assume, and we used gasoline to get here. The people who are watching this live are on a computer or a TV that uses electricity. Somewhere there's a plant probably burning a fossil fuel to fuel that. So we can just point the finger at, oh, it's industry and government. Each one of us has a carbon footprint. This slide here on the right is showing the areas. Road transportation accounts for 10%, electricity and heat 18%, industry 20%, and various factors. So all of those factors and all of these industries and everything exist for us. The clothes we wear, anytime you process some natural material, it takes energy, and almost certainly you produce, unless it's green energy, wind or solar, or nuclear we'll put in there, you're producing CO2. So everything that we wear, everything we touch, everything we eat, so we are the enemy to some extent. But we, being United States, we are the worst. We are number one, historically, as the chief polluter of the planet. And we only have about 4% of the world's population. We produce 25%, a quarter of the carbon. China, which has way more people, it's rising as they become more capitalistic, but they're investing so heavily for all their dirty coal plants, they're investing super heavily in clean energy, way beyond what we're doing here. And then Russia and other amounts smaller. The question then is, do Judeo-Christian ethics tell us anything about that in terms of what we ought to be doing? And make this short because I want to make sure we have time for questions. And I'm just about an hour and 5 minutes right now. So many people associate the Green Movement with the late Pope Francis. Pope John Paul spoke a whole lot about world peace is threatened by a lack of due respect for nature, by the plundering of natural resources, and by progressive decline in the quality of life. The greenhouse effect, this is 1990, has now reached crisis proportions. There's a book following St. Francis. St. Francis is the patron saint of environmental science. Even if you're agnostic or atheist, if you haven't read the prayer of St. Francis of Assisi, Google it. It's a brilliant prayer, even if you remove God from it. So Pope John Paul spoke a lot about global climate change and pollution. And then Francis is really interesting. He's the first in the history of the Roman Catholic Church, which dates to St. Peter as the first pope, who was a chemist. That's not widely known. His degree is actually in chemistry, and deeply connected to Catholic social justice theory. And he wrote this absolutely brilliant document. At the time it came out, I saw more articles written by atheist scientists quoting this document than I saw Catholics, which is a very sad state, but good that scientists were noticing it. He had just all kinds of great things to say about how we ought to deal with the planet. The Earth was here before us and it's been given to us. Doomsday predictions can no longer be met with irony or disdain. We may well be leaving future generations debris, desolation, and filth. So,
Tom?
yep.
Yeah, not long after Pope Francis wrote the Laudato Si, we had a presentation on the Sierra Club. We invited a Catholic priest to talk about it, and I read it thoroughly and offered some thoughts to the window.
It's really
a very moving piece of
there's some powerful language. Either he's a fantastic wordsmith, and I'm sure he had a team work on wordsmith. And it is. And it turns out there was a second one he also read that wasn't publicized quite as much. Where he said, I think I have that link here in a minute. Broader than Catholics, the whole Christian world, there's actually this organization, the National Religious Coalition on Creation Care. Really neat website, lots of resources where they talk again about this win-win between ecology and economics and justice. So, and Buddhism, again, that'd be another whole talk, but Buddhism, one of the phrases which shows up a whole lot in the Bible, that also shows up a whole lot in Buddhist literature. Buddhism precedes Christianity, but not Judaism, is loving kindness. Treating all of nature with loving kindness is both a Christian and a Buddhist idea. Back to Joseph Priestley, Unitarian Universalist. Again, Riverside Drive is our local one. They're the biggest house possible. You can be Buddhist, you can be Christian, you can be atheist, you can be agnostic, everybody's welcome. And again, that was founded by a chemist at the time of the American Revolution. Rather cool. But they have some strong statements. Earth is our home. We're part of this world and its destiny is ours. Global warming and climate change is resulting in more extreme weather. Our spiritual values call us to act on the personal, local, and national levels. So that's what I want to get to in the last 10 minutes here. Again, nod to Martin Luther King. The time is always right to do right. The time is now. Only in the darkness can you see the stars. We've had enough darkness. It's time to both seeing the stars and using them to guide us to a better place. So what can we do? A couple quick slides. Support and actively participate in citizen action. The Sierra Club is right here. They have a really neat website about actions. All these other environmental groups, and this is by no means a complete list, but there's quite a number of good environmental groups that deserve. I took that off, apologize. Almost all of these, except for Sierra Club, are not-for-profits. Sierra Club, because they do political action, is not a not-for-profit, so it's not tax deductible. All of them, the notion of think global, act local with science and social justice inform politics, policies and practices. Sierra Club has a really neat website and a training, Social Media Matters. You can be trained as a climate truth teller. It's a really interesting little mini course. A story that I've used in a lot of contexts, this story about 4 people named everybody, somebody, anybody, and nobody. And the last line, it ended up that everybody blamed somebody when nobody did what anybody could have done. So each of us have a part to play in small ways and perhaps larger ways to combat mis and disinformation and amplify positive messages. And this quote is directly from the Sierra, and that's exactly what we need to be. That's the Sierra Club is a leader. I call my 98-year-old mother, still lives alone. And I call her every night, and I told her it's going to be later. So I call her. I'm not sure what's that, but gotta love your mother. Annette, will you deal with us, please?
I'm not taking no for an answer.
Hit it on 7. I'm not sure why it's me, but anyhow. So political action, if you're a member of any of these organizations, probably on a daily basis, you get opportunities to give responses that send things to your congressman, et cetera. This is a couple examples from Earthworks, Stop Trump's Climate Chaos Plan. And again, I should point out, it's only in the very recent time that Republicans are anti-science and anti-environment. Teddy Roosevelt basically founded the national parks. President Nixon, not somebody I would hold up as a model, but he signed the bill that we got the Environmental Protection Agency. We had Republicans, some of the top Republicans in our state and others at one time were pro-environment. So this recent shift, they've always been much more pro-business, but they haven't been as strongly anti-science. So we can respond to things like that. In our state here, we have NIPERG, which is an organization that gives you opportunities. This was in October. Again, I probably get 5 of these a day because I support like 30 environmental organizations. Val sent out, and thank you. In New York State, there was actually a bill, an amendment to require climate education, and not just in science, because this is not just a science issue. This is great social studies, this is great math. At the grade levels, both at the end by the end of grade 4, at the end of grade 8, you're end of 12. Just the other day, yesterday was the deadline for responding to that. But if you think education is expensive, try ignorance. We've been doing that for some time. And we need to transform even science ed. Most people that get science, even if you have a chemistry major at the college level, you are not taught the evolution of ideas and that every chemical reaction actually matters. So we have people balance chemical equations that seemingly just because we balance chemical equations. No, that's logos. That's how the cosmos works. And there's a whole bunch of equations that have massive implications, particularly the one or the 2 that's on my t-shirt. Cellular respiration going one way, photosynthesis the other. So there was that opportunity. Really cool book for educators, The World Becomes What We Teach, and a website, Institute for Humane Education. Get outside and enjoy nature. Even now, it's cold, but if you dress right, today was a beautiful day. I got like an hour, 10-minute walk or so. It's good for you. And encourage schools to get outside of the 2x4, so the 2 covers of the textbook and the 4 walls of the classroom. If you limit kids' experiences to that, you're depriving them of a quality education. So outdoor education, bringing the outside world in more. So 2x4 produces bored students. And we make chemistry optional. Most people graduate high school and have not had a chemistry course. Chemistry defines how this whole planet works. That's really stupid. But climate education is a start. Again, Sierra Club, Triple Cities Hiking Club. The bottom line, all disciplines connect to this issue. And together, everyone achieves more synergy. So the bizarre, America First is scientifically just stupid. We can't control the air. We don't really control the water in terms of where it falls. So America First, no, we're all in the same boat. So we all need to work together and to solve those problems. Make America Green Again would be a nice motto. Wind and solar, despite the opposition from our current administration, is rising dramatically. There's been more increase of new electricity from solar in the last 3 years than any other source. Again, Chinese are beating. If you only care about economics, you should care about clean energy. And we're losing ground very rapidly to the Chinese. I'm going to skip over this slide, but a message I've tried to convey, and I've certainly touched on some gloom and doom, but also a sense of hopefulness, and that there are things we can do. This TED Talk, How to Transform Apocalyptic Fatigue into Action on Global Warming, is a cool one. And that's where this visual is from. So I'm not going to hop into that anymore. Transportation. We can walk, we can e-bike, we can drive less, we can carpool, we can ride share, we can use personal cars that have higher efficiency, we can use plug-in gas or electric hybrids, particularly if they're powered by solar, wind, and hydro. And in New York, you have the option of choosing where your energy comes from, and you can choose it to come from green sources. Transportation in New York State, according to NISAC, produces 34% of the climate change impact in our state. So how we transport people matters. Home energy, something as simple as closing your drapes when you're not wanting to get sun, using insulated drapes, programmable thermostats. LEDs are huge. You save a truckload of energy, a truckload of CO2, and actually a lot of money. The early bulbs that NISAC was giving out back in, gosh, it was 80s, one of them lasted in our living room for like 28 years, and we used that light more than any other light. That first gen, they were actually compact flash bulbs, lasted over 25 years. Using renewable energy as you can, use more efficient, replacing gas stoves with e-induction, boils water in less than a minute. You have a whole pot, or new one we got a year or two ago. It's amazing stuff. Insulate attics, windows, even putting bubble in windows that you don't need to see out, but you want the light. Bubble wrap adheres if you just put a little moisture on, put it up, works in both winter and summer. Lots of stuff we can do to save energy in the home. What we eat, old idea. In the early 70s, there was a really powerful book that I read in 74, 75 called Diet for a Small Planet. And the main argument was that eating red meat in particular is disastrous for your health and it's disastrous for the planet. That argument still holds true. So per 100 grams of protein, if you look how much greenhouse gases are emitted, and you compare beef to fish or grains or nuts. So if you're all about protein, you can get your protein in a much more energy efficient, less polluting way by what you eat. You can eat less red meat, eat more fruits and vegetables, home garden, use seasonal diets, minimize your waste, compost your waste, dine in more, eat out less, not overeat. Obesity is one of the biggest problems, health problems in our country, so not overeating. We have our newest food pyramid. Won't spend a whole lot of time on it, but the good, they minimize high calorie, sugar heavy. They call highly processed foods. They avoided the term that's used. Is ultra processed. Ultra sounds even worse than it is. Ultra processed foods and soft drinks and refined nutrient-stripped plant grains. Eat whole healthy things. The bad, they say we ought to that we all need more protein. That's questionable depending on the person. That whole grains don't matter. They put them at the bottom. Whole grains are actually very healthy. The ugly, consume red meats and saturated fats. This is not making America healthy again. So there's some great articles on the websites. PBS just literally in the last week started a new series called Horizons, where they're looking at social science issues. And the first one is actually on the American diet. So that's a cool resource.
Say that again.
PBS just started a new series called Horizons.
Oh, yeah, right.
Yeah, and I think this was the first issue. I just saw it today, actually. It's like, wow, that's cool. And you can speed them up and do them at 2 times. And so it works. Consume less. Tons of research show that the more we consume, the less happy we are. Actually, there's a whole lot of research. And those who have the most aren't the happiest. The old 3R has been expanded. 3R is still easiest to remember, but rethink, refuse, single use, reduce, reuse, refurbish, repair, repurpose, recycle. The notion of a circular, regenerative, sustainable economy that works the way the planet does. There is no waste in nature. One creature's waste is another creature's input. Brilliant, brilliant design. Law of conservation of matter. What does religion say? We'll wrap it up here. Whole bunch of quotes. Again, if you did a word search in the Bible, if you look at money, if you look at fear, and you look at hope, the Bible talks more about this too. And money, it's not that money is bad. It's the love of money. Putting money first over people is bad. And the Old Testament talked about, there's brilliant quotes there. The New Testament calls, and A whole lot of modern psychology has researched this. People that win the lottery is almost always their lives go to hell. Having more money is not the solution, particularly if you're not going to share it. So the Christian perspective is generosity and stewardship. Honest Day, President's Day, personified humility and honesty versus hubris. He said, the dogmas of the quiet past are inadequate to the stormy present. I think that applies now. He also, during the Civil War, established the National Academy of Sciences. Science has been under attack. Unbelievable attack on science. That's a disaster. We can't solve these problems without science. Truth is, there's lots of win-win solutions. I've touched on just a few. There's a really cool TED Talk, 100 solutions to reverse global warming. This is the top 20. Some of those we've touched on lightly: wind turbines, reduced food waste, plant-rich diet. Other ones we haven't had time to touch on. And biblical quote to wrap it up, Deuteronomy. Deuteronomy was when Moses, after wandering around in the desert, and sort of that's what we've been doing with climate change and energy conservation since President Carter left. If we had followed what he had laid out, we would be in a different universe. The Middle East would be totally different.
Yes.
Our massive investment in military would not have gone for the Middle East. We wouldn't have needed the oil. So Moses, after wandering around the people, if you know the biblical story, he doesn't get to go to the promised land. But he addresses the people and he says, I call heaven and earth as witnesses today against you, that I have set before you life and death, blessing and cursing. Therefore choose life that both you and your descendants may live. That is our choice. There's not another good planet to go to. Not even close. And even if there was, the percentage of our current population that could go to the new planet is 0.00000000001%.
You're doing a few people we might go.
Yeah, we might want to ship a few. So I thank you for your patience. That's a lot of ground. We've covered hopefully some fundamental answers, some basic science, maybe give you a little different perspective on Judeo-Christian overlap with science. But hopefully I've uncovered a bunch more questions to catalyze future learning on your part, because life is about learning. If you're not learning, why are you here? My dad on his deathbed, we're walking around hours before he died, and I asked him, Dad, what are you still doing here? He says, well, apparently there's still something I'm supposed to do. So as long as we're here, there's something we're supposed to do, and that's to make the planet better for all of us. So with that, I'll end. If there's questions, we'll take them. I don't know if we need lights or.
Online, Bruce Chamberlain asks, says, I saw on the Nova show that only about 10% of the Earth's last billion years were there ice at the poles, and that we are still coming out of the last ice age. I wonder how that plays into our man driving climate change.
Yeah, there's very large time scales in human history. The planet has been inhospitable for humans for almost the entire. So the Earth has been here, life has been here for about 3.8 billion years, and the vast majority of that time, not only were our genes not here, but the environment wasn't set up in such a way that we could have survived. And even during the times when we have trees the size of ferns and stuff, the amount of oxygen in the air versus CO2 was different. So some people looked at the fact that we talk about the ice ages. There actually was a brief period of time in the 70s where people worried about that maybe the planet was getting cool, too cool. All of those arguments that natural phenomena are the result, if anything, if we're heading into another ice age, the simple-minded might say, maybe that'll save us if we're naturally heading into another ice age, but we're melting the Arctic. One of the reasons why we care about Greenland is because how close it is to the Arctic. And the Arctic, which previously wasn't passable by ships, as more stuff opens up, then who owns the North? But that affects the whole reflectivity of the planet, which is going to make it even hotter. I don't think there's any reasonable scientific concern that the ice age is going to save us or hurt us. But when we look at temperatures over very, very long, much longer than 300,000 years, things have been very different at different times, but inhospitable to many forms of life. The planet and life will survive. Humans may not. The planet doesn't need us, except it needs us to know itself. Planet doesn't need us. Other questions here?
Where do we stand in schools today with regard to the climate change? I mean, we're mentioning all the words that are not supposed to be used, but obviously that doesn't apply except to the administration and what they're publishing. I'm wondering where do schools stand on all this? In terms of education?
I can't be positive about this. When I was teaching in the late 70s, there was more awareness of environmental and interdisciplinary than now. And most teachers, one of two things, either they've never been taught. Like you could major in chemistry and know nothing about how any of this applies to the planet. You could get a bachelor's degree in chemistry and know nothing about environmental chemistry. So most teachers haven't been taught, but then there's also a lot of self-censoring. So evolution, about people teaching evolution, for the most part, it's not taught. And if it's taught only as a topic, not as a theme. A famous Catholic Russian scientist said, nothing in biology makes sense except in the light of evolution. And yet evolution largely, for years we ran Howard Hughes funded institutes. Largely most people don't teach it. If they teach it in a very didactic, believe and be saved kind of way, which is counterproductive. And the same is true of environmentalism. There are wonderful exceptions, but the norm, and that's why this bill that we had sent out ahead of time for people to comment on is so important. Because it's the anybody, somebody, everybody. No, it's no science field picks it up. Social studies doesn't pick. I mean, it's a brilliant topic for social studies. How nations interact with each other and how the poor nations fare. No, our education system, and that's why I had the privilege for 38 years. I left the class. I loved teaching kids. I left the classroom to teach teachers because I felt I could impact more people. But the norm is not good. And so, I mean, most of these large percentage of Congress people went through Harvard in places. So people are getting degrees without knowing how that operating manual for the planet that was printed in 1969, most people have no clue about how the planet works. Anything else?
Yeah, unfortunately, the people that tend to rise into, at least too many of the people that tend to rise into positions of power, the arrogance tends to have them not listen to people that know more than they do. They think they're the smartest people in any room they walk into. And if somebody dares to say, hey, wait a minute, can you please listen to me for 5 minutes? I've got a real important problem I need to explain to you. They probably don't want to listen to you.
Yeah.
And even if they stopped for a brief minute and you tried to really speed up what you want to tell them, especially if it's about climate change, they're just going to give you the half smile and then say, thank you, I'll think about it.
We need to both inform, and that's why letters to your Congress people and stuff is useful. We need to inform the ones we have, and we need to elect a new generation of better ones. Yeah, you don't want to leave it just on, oh, the politicians are horrible. We elect them. And people that get, everybody gets to vote if you're of age.
Yeah.
So we need to educate our neighbors, not just teachers, education through our churches, through all kinds of venues.
And
we can make a difference.
The other side of that coin is there are people that are really passionate about doing the right thing. And they are trying their best to get their colleagues to do the right thing. They're trying to get enough people to support what they're saying. And we need to help them.
Yeah.
I know several of these people in our area that represent us. We are lucky to have them. One person in particular here who took over for somebody that used to represent us in Albany. This person now, I've seen it more than once at an event talking about a recreational trail between Binghamton University and Binghamton. It was a press conference to basically ceremonially say it's open, we're proud of this for our community. It took a lot of time and effort. This person brought up climate change at that press conference. And the other person that was there that also supposedly represents us did not. So there are
Yeah.
people that understand this and make the connections and want to talk about it in public.
Yeah.
And we need to support those people because that's how you get change.
And words matter. If people understood, again, the root of economics is numbers, eco is home. So ultimately, the economy, how do you manage your money in your house? And then the house ultimately is the country, ultimately is the planet. How do you manage money? How do you manage resources? And ecology, how do you manage the life support system for the planet? And so those two go together. That's a really positive message. Those two go together. China isn't investing in solar and wind and e-vehicles because their main motivation is they care for the worldwide health. I'm fairly certain, maybe I'm pessimistic, I'm fairly certain that's not their main reason. It may be a good secondary reason. They're doing it because they know that's where the future is and that's where the money is. So follow the money. But in this case, all of our money, whether it's even crypto, all of our money is based on the Earth's resources. If you screw those up, the whole game is up. You can't have economics without ecology. And curiously, The Wealth of Nations, written by Adam Smith, that is, people always, oh, The Wealth of Nations. The book he wrote as the corollary of that was The Theory of Moral Sentiments, not read by many people, where he basically lays out and says very clearly what later Teddy Roosevelt said, is the rich had an obligation to act in the interest of the broader good, even if it wasn't in their own interest. That's a founding document. Again, the corollary to The Wealth of Nations, Adam Smith, 1770s. Our country made use of the Wealth of Nations to establish a capitalistic system. The second book, there was going to be a trilogy, but he only wrote the second one, is The Theory of Moral Sentiments, where he absolutely says greed is not good, basically. Yeah. So there's a lot of good stuff out there. I'm sorry.
Oh, I was going to mention that one of the Chinese movies, they are a strong cause of optimism because of climate change. Last year, I think they created like 400 gigawatts of nuclear. A gigawatt is a nuclear reactor.
Yes. Yes.
Their influence in Africa is huge. In 2025, their exports actually increased in spite of tariffs by the US. A lot of that increase was in Africa, huge percentage increase into Africa. They're able to set up.
Which is the
systems,
fastest growing populations.
growing population and getting them off the right foot, getting them started on renewable energy instead of getting addicted to fossil fuel nonsense. These are countries in the global south, predominantly with lots of solar resource. And why bother getting hooked up to it?
I'm delighted with the Chinese, and I hope I didn't leave the impression of not. It's just we should be in a real
We're studying on
competition to do best for the whole planet.
Yeah.
What a wonderful problem if both China and US were pro-environment, and that would be a great problem to have.
Well, the good thing is we're only 5%
Population.
population, but okay, there's a lot, 95% of the rest of the world is ready to accept cheap Chinese cars, cheap Chinese solar, and the Pakistan is not underserved, including the Chinese solar panels, because they're not afflicted by tariffs. You probably really like in Pakistan. It's the panels are cheaper than the hardware to set them up on. So they just put them on the ground and using the pumping water. So that's an example. Something good happening in the rest of the world. Regardless of how idiotic the United States is. And the other thing is that perhaps we can move this to a few years. Keep the pressure on where it can be kept. And hopefully after we come over the jump curve, if that happens, then we can get back on the true path to cleaning up the atmosphere.
Yeah. And again, this is one case where I think ultimately, if we follow the money, it's already happened in Republican states, as we mentioned, with respect to wind and solar. So it's Trump is a blip.
They'll slit their throats just to remain loyal to Trump. In spite of the fact that they do.
The psychology and the sociology of this, that whole dynamic is, that would be more than an hour talk for sure, but yeah. I threw up one more slide, just in addition to the various TED Talks and stuff, in New York State, one of the individuals who's worked a lot on, in fact, was part of the push to get climate education in our country is a friend by the name of Don Haas, who works over the PRI just over Ithaca Way. And he gave an interesting talk. The title, when I first saw it, is like, this is sort of the antithesis of what I'm talking about, but the alignment actually is much stronger. Fear is our best hope, moving from climate anxiety to climate action. And his slides are available. And then our own, we mentioned at the start of the talk, Dr. Julian Shepard, recently retired from BU, gave a great talk that's posted on the Sierra Club website. So I'll leave
Can
with
we
that.
get your slides?
There's a vehicle to do that, yes. And I waited a while for Julian's talk because I couldn't be here. I was actually doing another presentation that night, I think. So I can send these to whoever.
Because you have a lot of information
All the links.
and all the links, they would work if we had, so we can put it on the website. And if you send it to Wally or me, you got both our emails.
Okay. Anything else pressing on your end? I really appreciate your patience. That was a
Thank you.
long run.
Yeah, thank you
Stay
very
with-
much, and especially your visual, because one of the things that I always hear from the naysayers is, oh, how can this, a few hundred parts per million make such a big difference? But when you can actually see it compared to this cubic meter, it's like, yeah, you can see it.
One thing I
No.
did mention about some of when you get your water bill, there's a few things that are listed in parts per billion. And a billion, if I had a cubic millimeter, that's 1,000 times 1,000 times 1,000. That's a billion. And the closest thing is a crystal of salt. If you look at a table salt under simple hand lens, it's a perfect cube. It's a little more than a cubic millimeter, but it's the closest thing you can find in nature that is a cubic millimeter. Imagine lining up 1,000, 1,000 and filling in and then going 1,000 up, but a part per billion. But small things can matter. Gases have mass and gases matter. And so doubling the CO2 upsets the whole system. So yeah.
Yeah, it's a shame that carbon dioxide isn't visible, because when you think about like Los Angeles smog, I mean, that's highly visible, everybody can see it, the nose crappy, and that again was produced by part per billion less levels of pollutants. Here we're talking about 300 parts per million.
Most gases are invisible. There's a few.
I know it's invisible, it's.
Yeah, there's a few like the nitrogen dioxide.
If it were visible, people would be, up in arms about it, and like they were about photochemical smog in LA, so they started doing something about that.
And unless you have.
Because you can't see it, it's only a few hundred parts.
Rule of chemistry, just because you can't see it, doesn't mean it ain't there.
Yeah.
Atoms are, we can't see the fact that there's room that's filled with atoms, but at the gaseous level, there's vast differences between them. I mean, most of this is a vacuum. You condense all these, but they move so fast that operationally it's like a fluid that is continuous, but it's not.
Yeah, if you think about it, you think about the other things, the catchment part. Even though the atmosphere is thin, you do have, say 25 miles of matters. You have 25 miles of your 300 parts per million. And that's a lot of absorber. That's trapping the heat that's trying to come up here.
Teaching people scale is something we don't do well in any of the sciences, and we don't even do it in that. People do exponential notation or something, they don't teach them why it actually matters. So scale, including the things we can't see, including the very large things, until the space program, we couldn't see Spaceship Earth. People knew it, the ancient Greeks knew it, actually, the ancient Earth was flat. It's so that
Kind
kind
of the apple skin analogy or the illustration, I think that's a very good illustration. Because the blue marble thing, you really need to add something that shows here, this is what the thickness of the atmosphere is with respect to that, 2,000 miles.
And for the most part, every picture that's in a science book, almost all of them lie. And they lie when they don't have to lie, that's criminal. But they lie when they have to lie, but they don't tell you they're lying. And so all the pictures, people think like you know, a mitochondria is the size of the planaria or something. All those images lie. Most of them have to lie, but they should tell you what they lie. So that one image I showed, not to scale. Almost every picture in the science book should say not to scale. Even things like the Earth and the Moon. You have never seen the right scale on the Earth and the Moon, and I could do it in this room. I had a basketball Earth right here, and I threw you a tennis ball. If I walk out 30 basketballs, that's where the moon is. You've never seen a picture like that. And that's one of many, many examples that we all regularly teach it. We don't.
But
We could.
I've got one thing that, I don't know if you've thought of this, but if you want to tell people, have we ever seen climate change? My answer is yes. Summer of 2023 with Canadian wildfire smoke. That's climate change that looked like a bad science fiction movie that you don't want to continue living in. It was a taste of the future to come.
Right.
But it's going to come back again. It's just a question of when.
Well, we saw the floods. I live on a suburban lot, but it's got woods on it, and a little creek. That creek became a roaring mountain stream. If I had blew out a ditch this wide filled with gravel and two pipes that fit, blew out the gravel from here to the corner out into the street, it would have gone through my neighbor's yard, but I set up a barricade because the original stream 50 years ago cut right through those houses, and the stream was just going to reassert itself.
Oh.
That was visible.
Oh, yeah. Yeah, floods too, but people don't make the connection. But when you see the sun blotted out in the middle of the day and people are all asking questions, what is this? I told my backyard neighbor, I said, you want to know what this is? This is climate change. You say it doesn't exist. There it is. Right in front of you.
Yeah, it's now.
Yeah.
It's in my backyard. It's
Yeah.
not later or in somebody else's yard.
Yeah.
But again, we have all these win-win solutions. The sustainable goals, we can reach all of those are interconnected. And that's really cool. When you get positive feedback loops that solve multiple problems at once, that's synergy. That's cool. That's the way science works.